Hi everyone. So today we are going to do another question on the subject DSL data structures and algorithms. The question is coming under single English. So can we see the question first? So this is the question in English or single English. Okay. This is the pseudocode. So this all are the pseudocodes of the experiment code. Sorry, the question. So this all are the pseudocode of the question. So can we now go to the coding part? This is the code coming under this. So in this we are using elif self and data, and we use a single index. In this we are using we are using add and b. So this single it's a menu-driven Python program that implements a single list with common operations like insertion, deletion, and display. The program defines a single node class where each node stores data and a link to the next node. The single linked list class that keeps a start pointed to the head of the list, and list is created start is none, which means the list is empty. The added back data method creates a new node, makes its link point to the current head, then updates start to this new node. They insert the value at the beginning in constant time. The add at end of data method also creates a new node, but if the list is empty, it sets start to the new node. Otherwise, it traverses from the head to the last node and sets that the last node's link to the new node, thereby appending to the tail. The add at post method inserts at a specific one-based position. It threads position one at the beginning, validates that post is positive, travels to the node just before the target position while checking for out of range situations. Then link the new node into place so a list remains connected. If the requested position is beyond the current list, like the method prints an error. The delete method first checks for an empty list, then handles deletion of the first node especially by moving start to the next node if the head contains target. Otherwise, it travels keep tracking of the previous node and when it finds a node whose data matches num, now it removes it by linking previous link to tumbling. If traversal finishes without a match, if it reports the element was not found, the display method prints list is empty. When there are no nodes, otherwise it traverses from start and prints each node. Data followed by an arrow until it reaches the end and print none to indicate the termination. Finally, the program runs a user interactive loop that shows a menu with six choices inside a beginning insert at position insert at end delete element uses choice collects any required inputs uh, calls the corresponding single linked list method and repeats until the user selects exit. The structure demonstrates how linked lists manage dynamic collections of data, how insertion and deletion are performed by adjusting pointers rather than shifting elements, and how careful boundary checks keep the implementation robust for real lists. So this is the code which is coming under the single linked list. We're using the operators of the single list in this, and then we're using the menu driven also in this, and we have the this all are the operators of the single list display, delete, insert. So this all coming under the single list operators. So after that, we have a minute program of six options. So it's under that, each condition is given. So this is only good. So thank you and have a great day.